video, we're going to write formulas for ionic compounds with just two elements, which are going to be called binary compounds. So in an ionic bond, it's a metal plus a nonmetal, which is a cation and an anion. Cations always come first, anions always come second. It's a type of chemical bond that involves the electrostatic attraction between oppositely charged ions. So here's your sodium, here's your chlorine. Sodium's going to give an electron over to the chlorine, and then the loss causes it to be a positive one charge. This gaining becomes a negative one charge. So, will the following combinations be binary ionic compounds? Yes or no, and explain why. Fluorine and fluorine? No, because it's two nonmetals. You have to have a metal plus a nonmetal. Sodium and chlorine? Yes, that's a metal and a nonmetal. Nitrogen and sulfur? No, two nonmetals. Sodium and calcium? No, two metals. Has to be a metal and a nonmetal. And then calcium and argon, that's tricky because that is a metal and a nonmetal, but because argon is a noble gases do not react, so no, this will not form a binary ionic compound. Writing formulas for binary ionic compounds. The sum of the positive charges must equal the sum of the negative charges for an overall charge of 0. So if we write the ionic formula for sodium chloride, find sodium on the periodic table, it's in the alkali metals, which gives it a +1 charge. Chloride is in the halogens, and that gives it a -1 charge. Since +1 and -1 are equal and opposite, then these two cancel with each other and have an overall charge of 0, because we have a total of +1 and a total of -1. Therefore, I only need one sodium, subscript of 1, which we don't write, it's understood, and only one chloride, subscript of 1, again, it's understood. So the ionic formula for sodium chloride is NaCl. Notice on our formula there are no charges, no superscripts, only subscripts, and in this case, subscripts of 1, which are understood. Next example is aluminum oxide. Aluminum on the periodic table is Al with a +3 charge, and oxide is O with a -2 charge. If I want to balance +3 and -2, I want to consider a common factor of 3 and 2 is 6. So if I can have a total positive charge of 6 and a total negative charge of 6, then these would be balanced. So it takes 2 aluminums, 3 plus 3, to get me my overall +6 charge, and it's going to take 3 oxides, each at a -2, to give me -2, -4, -6, my overall -6 charge. And so the formula would be Al, a subscript of 2 because it took 2 aluminums, and O with a subscript of 3 because it took 3 oxygens, in order to find a balance of my positive and negative charges. So the ionic formula for aluminum oxide is Al2O3. Write the ionic formula for lithium oxide. Lithium is an alkali metal, so it'll have a +1 charge. Oxide is going to have a -2 charge on the periodic table. And now I want to balance out 1 and 2. And so I'm going to need another lithium with a +1 charge to give me that overall +2 total charge, which is going to be equal to the oxide's -2 charge. And so the ionic formula is going to be comprised of 1, 2, 2 lithiums written as a subscript, and then just 1 oxide. Subscript of 1 is understood, we don't write it. So the ionic formula for lithium oxide is Li2O. Next example is potassium nitride. Potassium would have a charge of +1, K being the symbol for potassium. Nitride is going to be N-3. Both of these are found on the periodic table. Now, I want to balance +1 with -3, so we're going to need 3 +1s, which will give me my overall +3 charge, which balances that -3 on that nitride. And now that I have these balanced, the formula is going to be K with a subscript of 1, 2, 3, and then N with a subscript of 1. And so the ionic formula for potassium nitride is K3N. Now pause the video and attempt these, and then unpause the video to check your answers. So the answers are sodium oxide would have a formula with 2 sodiums for every 1 oxygen, potassium phosphide, 3 potassiums to 1 phosphorus, aluminum bromide is going to be 1 aluminum, 3 bromides, magnesium phosphide, 3 magnesium to 2 phosphides, aluminum nitride, they were equal and opposites, so they canceled, which meant I only needed 1 of each. Same thing with calcium sulfide, they had +2, -2, canceled, only need 1 of each. Strontium fluoride, +2, -1 means I need 1 strontium, 2 fluorides. Lithium chloride, equal and opposite, only need 1 of each. I needed for rubidium sulfide, 2 rubidiums, 1 sulfide to balance the charges. And then you can see the rest of them. Now choose the correct formula for the following pairs of elements. If I have sodium sulfide, then the correct answer would be, and it's going to depend, what are the charges of each of these? Well, sodium has a +1 charge, while sulfide has a -2 charge. And to balance these, that means I'm going to need 2 sodiums for every 1 sulfide. And so the formula I choose should have 2 sodiums to every 1 sulfide. What about aluminum chloride? Well, look at the charges. Aluminum is a +3 charge. Chloride is a -1 charge. And so to balance this +3, I would need 3 chlorides for every 1 aluminum. And so I would choose AlCl3 because that's 1 aluminum for every 3 chlorides to have a balanced ionic formula. Ternary ionic compounds are a compound that contains 3 or more elements. They have a polyatomic ion. So to write the formulas for ternary ionic compounds, you write the symbols and the charges for each ion, you balance the charges, and then this is very important. If you need more than 1 polyatomic ion, you have to use parentheses around the polyatomic ion, and you put the subscript on the outside of those parentheses. So what that looks like is we have calcium, which is Ca+2. Nitrate is a polyatomic ion because we know it because it ends in 8. And so that's NO3 with a -1 charge. To balance these, I'm going to need 2 -1s to balance that +2. So I just need 1 calcium and I need 2 of the nitrates. Since we need more than 1 nitrate, it's going to go in parentheses and the 2 will go on the outside of the parentheses. Let's look at another example. Tin,4 sulfate. Tin,4, the Roman numeral 4 tells you the charge, so that's Sn with a +4 charge. Sulfate, because it ends in 8, that's how we know it's a polyatomic ion. It is SO4 and has a -2 charge. To balance the charges, it's going to take 2 -2s to balance that +4. So I'm going to need 1 tin and 2 sulfates. Because I need more than 1 sulfate, which is a polyatomic ion, I'm going to have to put it in parentheses and put the 2 on the outside of the parentheses. One more example, strontium hydroxide. Strontium is Sr with a +2 charge. Hydroxide is a polyatomic ion, OH -1. To balance the +2 and -1, it's going to take 2 -1s for 1 +2 charge. So I'm going to put Sr, because this is 2 or more elements, I'm going to have to put it in parentheses and put the 2 on the outside of the parentheses, even though it doesn't have a subscript like the nitrate and the sulfate did. Now you're going to use your periodic table and polyatomic ions and write the formulas for these. Pause the video and then we'll go over the answers after. Iron 2, iron Roman numeral 2 is our cation, and acetate is our anion. Cations always come first, anions always come second. Iron 2 is going to be Fe with a +2 charge, and acetate is going to be CHO, CHO, 232 as our subscripts, and has a charge of -1 or -1. So I need to balance the charges now. It's going to take 2 of these -1s to balance out 1 +2. So I'm going to need 1 iron, and I'm going to need 2 sets of the acetate. So when I rewrite the formula, it's going to be 1 iron, subscript of 1. Because I need more than 1 polyatomic, it's going to have to go in parentheses. So I'm going to put the acetate in parentheses, and then I'm going to put a 2 on the outside of the parenthesis to denote that we have 2 acetates. Next is silver nitrate, and silver is my cation, nitrate is my anion. So silver is Ag with a +1 charge. Nitrate is a polyatomic ion. It's NO3 and has a -1 charge. So when I look at the charges, they're equal and opposite each other. So +1 and -1, because they're equal and opposite, means I only need one of each of my cation and my anion. So when I rewrite this formula, it's going to be Ag, just 1. We don't write the subscript of 1. And then I only need 1 nitrate. Since I don't need more than 1, it does not need parentheses, and it'll just be AgNO3. Next is cadmium nitrate. Cadmium is Cd with a +2 charge, and nitrite, notice this one is different. Before it was nitrate, which is NO3 -1. Nitrite is going to be NO instead of 3, 2 -1. And so now that I have my ions, I'm going to balance the charges. This +2 versus -1, I'm going to need 2 -1s to balance that +2. You can think of it as 2 times -1 is -2, which balances that +2. So I'm only going to need 1 of the cadmium. So my formula is going to be written as Cd, subscript of 1, which we don't write, and then notice I need 2 nitrites. Since it's a polyatomic ion, I'm going to put nitrite, NO2, in parentheses, and then a little 2 subscript on the outside. I hope you've also noticed that we don't use charges. After we balance them and figure out the subscripts, we do not put charges on our final answer. Next is going to be ammonium phosphide, and ammonium is a polyatomic cation. This is my cation, this is my anion. So ammonium is NH4 with a +1 charge, and phosphide is P with a -3 charge. And so now that I know these, I'm going to balance the charges. It's going to take 3 positive ones to equal this -3 over here on phosphorus. So I'm going to need 1 phosphide and 3 ammoniums. And so when I write that formula, it's going to be, since I need 3 ammoniums, it's a polyatomic, so it's going to have to go in parentheses with a 3 on the outside. NH4, 3, and then I only need 1 phosphide, so I'll put a P for the phosphide. Ammonium acetate. Ammonium again is NH4 with a +1 charge. Acetate is C2H3O2 with a -1 charge. Okay, so we have ammonium and we have acetate. Notice the charges are equal and opposite, +1 -1, so they'll cancel, which means I just need 1 of each of my cation and my anion. So when I rewrite this as a formula, I just need 1 ammonium, so no parentheses necessary if you only need 1, and 1 acetate. No parentheses again because I only need 1. And remember, we don't put the charges on the final answer. So we just need 1 ammonium, 1 acetate. Ammonium phosphate. Ammonium is NH4 +1, and then phosphate is PO4 with a -3. I need to balance the charges. It's going to take 3 +1 ammoniums to 1 phosphate for this to be balanced. And so when I rewrite this as a formula, I need 3 ammoniums, so it's going to have to go in parentheses. NH4, no hate for the positive ones, put a 3 on the outside of the parenthesis, and then I only need 1 phosphate, so I don't need parentheses around the PO4. I'm just going to write PO4. Again, no charges on the final answer. Last one is sodium carbonate. Sodium is Na with a +1 charge. Carbonate is CO3 with a -2 charge. So to balance the charges, I'm going to need 2 positive 1s to 1 negative 2. And so when we rewrite this as the formula, it's going to be Na with a subscript of 2. And then because I only need 1 of CO3, I do not need to put it in parentheses. It's just going to be CO3. Now your turn. Pause the video, attempt these, and then unpause to check your answers. Okay, here are all of the answers. Please take note that hydroxide, when you need more than one hydroxide, it must go in parentheses with the subscript on the outside of the parentheses to show that you have 3 sets of oxygen and hydrogen. So write the correct formula for each of the following. Take a moment, use your notes, and see if you can get the correct answers. Pause the video, unpause when you're ready to see the answers. Number 1, aluminum nitrate. Aluminum has a +3 charge. Nitrate has a -1 charge, which means I'm going to need 1 aluminum and 3 nitrates. Since nitrate is in a polyatomic, it's going to have to go in parentheses with 3 on the outside of the parentheses. So it's going to be letter C. Nitrate is NO3, and then we need a subscript of 3 to show we have 3 sets of nitrate. Next is copper 2 nitrate. Roman numeral 2 tells me this has a +2 charge. Nitrate has a -1 charge. So it's going to take 1 copper and 2 nitrates for this to be balanced. And so I'm going to need nitrate, which is NO3, inside of the parentheses with a 2 on the outside of the parentheses, and only 1 copper, which is going to be letter B. Next is iron 3 hydroxide. This has a +3 charge. Hydroxide has a -1 charge. So it's going to take 1 iron and 3 hydroxides for this to be balanced. And remember, the hydroxide, OH, must go in parentheses with the 3 on the outside of the parenthesis. And so letter C would be the correct answer. Last one, 10,4 hydroxide. Roman numeral 4 tells me this has a +4. Hydroxide has a charge of -1, which means I'm going to need 1 10,4 and 4 hydroxides. Again, you're going to need the OH to be within the parenthesis and the 4 next to the parenthesis to indicate 4 hydroxides. Match each of the following with the correct name. Pause the video, give it a try, unpause to see the answer. Sodium CO3 is carbonate, so that will go here. Mg, magnesium. SO3 is sulfite, because sulfate is SO4, sulfite is SO3. So this will be magnesium sulfite. And then this one is magnesium sulfate. And finally, sodium chlorate. So get ready to do a whole lot of formula writing and naming.